Hey everyone, welcome back. If you're new here, I'm Andrea and I'm a member of the core team of the Elixir programming language. This video is episode 5 in a series I'm making on solving network programming challenges in Elixir. If you haven't followed along, I recommend starting from the first video of the series, which is linked up here, where I give you some context on the whole series and we get set up in order to follow along. If you're up to speed, then let's get going. So today's problem revolves around UDP, and for the first time since the start of this series, we're going to use a different transport layer protocol other than TCP, so that's going to be UDP. I'm leaving a link in the description with more information about UDP so that you can go read and have a more in-depth understanding of the UDP protocol itself in the description below. Compared to TCP, the gist of UDP is that it's faster, but it's less reliable. So it sacrifices guarantees about the delivery and ordering of packets to slim down the server-client interactions and make exchanging information faster. So okay, enough about the protocols. Let's get our hands dirty by going through the problem description. We're building a key value store over UDP. ProtoHackers is nice enough here to basically allow our server to not care about the fact that UDP is an unreliable protocol. You can kind of see that highlighted here, where it says client have to be careful to not send requests too fast and have to accept that some requests or responses may be dropped. So it's kind of the client's responsibility to take care of that. We also don't really have a protocol per se. Each request is a single UDP packet, as it says here. And then there are two kinds of requests, insert and retrieve requests. A request is an insert request if there's at least one equal sign in it. So just if there's an equal sign, then it's an insert request. Otherwise, it's just a retrieve request. For insert requests, we don't need to send a response. For retrieve requests, we should write a similar message to what we get for insert requests. So if we get a retrieve request for a key, we'll just write the key equals its value, similar to what we get to set a key. There is also a special key that we need to take into consideration, which is this version key. We should set this key to a constant value and not allow clients to change it. That's part of the specification. Last but not least, the problem description sets a maximum of 1,000 bytes for each request and response. And we are ready to go. Okay, so as I mentioned, UDP is quite different than TCP. The first thing is that the socket acceptor pattern that we use for TCP doesn't really apply here. If you want to handle multiple UDP connections concurrently, you have to listen for UDP connections on multiple ports. So let's start for now with a Gen server from scratch, which will be our UDP server. So I'm going to go with creating a file in protohackers/udp server.ex. Okay, I'm going to open this up and we're going to do dev module protohackers.udp server. As I mentioned, it's going to be a Gen server. It's going to have a start link function, which is going to take no options. And it's going to call Gen server.startLink module, and it's going to have no state for now. I also want to require logger because we'll use that later. Okay, let's go with our init callback. We'll say enable true, def init. It takes no state as we passed, and we can return just a struct, which we're going to define here as the state. For now, I'm just going to use store as the empty key value store that I mentioned. So the store field of the struct is a map, which will represent our key value store. And it's initialized as an empty map. So when I'm going to create a new struct, it's just going to use this value. So we're good to go. Let's also add this as a child of our application supervisor. So protohackers.udp server. And let's make sure that we can still run all of these. Okay, all of our previous servers are running, so we're good to go. No errors. So for our UDP socket, Erlang luckily ships with a Gen UDP module, which is what we're going to use. It's similar to Gen TCP, but it deals with UDP, obviously from the name. The function we'll use to listen on a specific port is genudp.open, which we'll see in a second. UDP's idea of servers and clients is kind of wonky. You can open a socket on a port, and there you go. You just kind of have a server and a client on that socket. You want to connect to a UDP server as a client, then you just open that socket on a port and then send data to an address, to the address of that server. And then you're a client, you want to be a server, just receive data instead. So we're going to see both sides. We're going to see the server side here. We're going to see the client side in tests. So let's get going. So let's open our UDP socket on port 5005, which is the next port in our sequence of ports that we're using for our servers. So I'm going to first of all add it to the struct that represents the state here. I'm going to say socket. Okay. And then I'm going here to, first of all, log something, say starting UDP server on port 5005. And then I'm going to say case gen udp.open, and I pass the port, and then I pass a bunch of options. Here, I'm going to say again, binary, so that the messages that are exchanged are binaries. I'm going to say active false, like we did in all previous videos, to make the receiving operation blocking, so that we're not going to use really Erlang messages yet. We're going to do that from the next video. For now, we keep things simple and we do blocking operations. And then I'm also going to set the receive buffer to 1,000 bytes so that we don't receive more than 1,000 bytes at a time, since that's what the problem description specified anyways. Okay. We're following part of the pattern. So if this returns a socket, we're following part of the pattern of what we did with TCP. So we start the socket, then we move to a handle continue callback by returning continue. So in this case, I'm gonna say that the state is now module, and I stored the socket in here. And then I'm gonna return okay, the state, and then I'm gonna return continue and something like receive, because I'm gonna go in a receive loop. Okay, if there's an error opening the socket, I'm just going to stop the server with that same reason, which is kind of what we did with the TCP as well, similar approach. Okay, now let's write our handle continue callback. So I'm going to say impl true again, then handle continue receive, as we said, and then I'm going to make sure that this is the state. Perfect. Okay, and then what we're going to do, this callback is essentially going to do an infinite loop where it keeps receiving from the socket, handling a request, and then going back into the recursive loop. So what we're going to do is we're going to call gen udp.receive, and this takes a socket. It takes an amount of data. So 0 means all available data, like in TCP, and it takes a timeout. I'm not going to go with a timeout here because anyways, we're going to sit here and just wait for data, and the server is going to be blocked. So let's just pretend the default is infinity. So let's just go with infinite timeout. It's going to be stuck forever until the application is running, until it receives some data or an error. And if we get data, the data looks a bit different in TCP. So in TCP, we would just get data here. Here we get a tuple, which is made of an address, a port, and a packet, or we can call it data, but let's go with packet. So packet is the equivalent of the data in TCP, so it's a binary in this case. Address and port are the source of the packet that we got. So it's the IP, address, and port combination of the socket that sent us the data. Perfect. So for now, we're just going to debug received UDP packet from, let's say, inspect address, inspect port, inspect packet. So we kind of debug everything. Perfect. And then we would return no reply, the same state, and continue receive to go back in the loop. If this returns an error, we're going to kind of cheat here and, go out of this really easily, which is we're going to stop the gen server with that same reason. The supervisor is going to restart it. So if there's an error, it's fine. It's going to restart it. It's going to listen to the same port. So it's kind of going to be up again. So we're just going to cheat here and not really handle this in any more elegant way. It's fine. Okay, let's test this option out with Netcat. So if we use the -u option, Netcat can send and receive UDP packets as well. So we're going to do, we're going to start our server first of all by doing mix run no halt. And we see starting UDP server on port 5005. And then we're going to do echo foo, for example. And we're going to use Netcat, the -u option, localhost, and 5005. Nothing happens here, but we can see that we have a debug log, received UDP packet from, this is the IP address, it's my IP address, a home, of course, and a port that got picked by Netcat, and then we got our data. So looks like it's working well. The new line here is because we use echo, but yeah, it will not be here otherwise. Okay, so it looks like it's working. Let's move on to handling insert and retrieve requests. Okay, so inserting is pretty straightforward. The only interesting thing about retrieving instead is the way we use genudp.send. Okay, let's write some code. So I'm gonna change potentially the state based on the request, and I'm gonna say case string.split packet on the equal sign we said, and I'll use the parts2 option so that if there are multiple equal sign characters in this string, only the first one is going to be used to split the string, and the right side of the split is going to contain however many equal signs, which is what the problem description specifies. So if this returns two strings, it means that there was an equal sign and the string got actually split. So this would be key value, and this is an insert operation. So I'm going to say logger debug inserted key with value, inspect value. Let's actually inspect the key too, so that if it's like an empty string, it's going to be easier. And we want to update our state, right? So I'm going to use put in with accessors. I really like these. I'm going to say state.store key value. So this is going to, the whole thing is going to return the state, but I can go dig into the state and into its components to actually store something in there. If I get just a string from splitting, it means that there was no equal sign character. So it's a retrieve request. So in this case, I'm going to say logger debug requested key inspect key. And I'm just going to generally return the state, but I also want to reply to the client, right? And this is the only interesting thing really about this part of the problem is how we use genudp.send. So the socket itself is not really enough for sending. We also need an address and a port to send to. Since we want to answer to the client that sent us this UDP packet, we will use the address and port returned by genudp.receive, which are here. So we're going to construct the packet by saying packet equals, essentially it's going to be key equals value, the value is state.store key here. Yep, that's the value. And we're going to send these with genudp.send, and it's going to take the socket, and it's going to take the address and the port and the packet. There is something wrong. This is state.socket. So we could potentially, and then we keep returning the state here and everything is fine. We handled the request. There is a way to not have to use address and port here, which is by using genudp.connect. So you can connect a socket that you have opened to a specific address, but the only thing that does is stores that address in the socket, and then that socket is kind of bound to only talk to that address, so by sending or receiving only from that address. But it's the thing that's done by genudp. It's really just storing the address in there and making sure that the data only comes and goes there. But in our case, we can just reply to the client that sent us the request in this case. Okay. Let's try this out with Netcat again. I'm going to run the server once more. Okay, let's run this again. I'm not going to use a new line this time. I'm going to say -n so that the new line doesn't get included by default by echo. And we get foo equals nothing because there's no foo value. What if I try to, but if I go here, I say requested key foo. So it's actually working. If I say foo equals 1, it's not going to return anything, but it's going to say inserted key foo with value 1. So that's fantastic. If I retrieve it now, well, we have foo equals 1. What if I try to update it? Foo equals 2. No response, but if I get foo, now it's 2. So it seems like it's working. This is not going to, the data is not going to survive server restarts, but it's fine for now. It's fine for us especially. Okay, so now let's write some automated tests. I'm going to create a new test file, test protohackers UDP server test.exs. Okay, and this is going to be protohackers.udp server test. And I'm going to do use xunit.case and saying true. And I'm going to write a test. It's something like insert and retrieve requests. Okay, so the first thing I'm going to do here, I'm going to open a UDP socket, which is going to act as the client. So genudp.open. I'm going to use 0 as the port number, which is a special value that essentially means tell the operating system to assign a free port to this socket. We can retrieve this port with there's a function called inet.portNumber in Erlang, and it gives you the port of that socket if you want to know after creating the socket if it was assigned and what is it, but we don't really need that here, so we're just not going to care. And then we have a bunch of options here too. I'm going to use binary and I'm going to use active, true, false, I meant here as well to have a corresponding socket. And I'm also going to use receive buffer 1000 just to match what we had on the server. Okay, and then what am I going to do? I'm going to send data genudp.send to the server. So I'm going to say the socket, and then I'm actually going to say an IP address, which is the home address, and a port. So that's where I know that the server is running. And the packet that I'm going to send is foo equals 1. And also I'm going to make sure that this returns okay. Then I'm going to retrieve this thing. So I'm going to send another packet that's just foo. And then I want to receive something that says assert, okay. We don't really care about the address and port because we know it's the server anyways. And we want to assert that we get foo equals 1 back when I do gen udp dot receive socket all available bytes. Okay, let's actually run this test. Yeah, it passes. Let's make sure that we can also update a value. So I'm going to copy all of these and I'm going to say foo equals 2. And make sure that if I request it again, now it's 2. And this passes. Okay, the last thing to do here to have the solution to the problem is support the version special key. To support retrieving the version, what I'm going to do is I'm going to kind of seed the version in the store initially. So I'm going to say version is like proto hackers in Elixir 1.0. Okay, so we're going to have a version key in here that's going to just return always proto hackers in Elixir. And the other thing we need to do is prevent clients from updating the version. So we can add an extra clause to here where it says if you're trying to change the version, so the key is version, but whatever value, then we can just return the state and we can say something like don't do anything for the version key. Okay, so this should prevent the version from being updated. We can write a test for retrieving and trying to change the version. So we can say something test version. I'm going to copy all of this. And I'm gonna kind of do some surgery here. So let's say that if I try to set version equals foo, it shouldn't do anything, and I can verify that because if I request the version, this is gonna return version equal proto hackers in Elixir 1.0. Okay, if I test this again, all tests pass. Fantastic. So our server is ready for being deployed. The one thing we need to do still though is specific to fly.io. In their documentation, they specify that UDP sockets should bind to a specific address rather than our usual 0.0.0.0. The address is like fly-global-services. We just have to bind to that. Erlang, GenUDP and GenTCP and all other this sort of modules for networking, they don't really have a way to bind to string addresses. They have a way to bind to IPs. So we're going to do that by just resolving that IP, essentially. The only thing is that we have to conditionally do that based on whether we are on fly or not. And the way we're going to do that is essentially we're just going to say address equals, and we're going to look at an environment variable that is set on fly. So one that I used in this case is fly up name. So this is set if we're on fly, it's not set locally, right? So if this returns something, it means that we are on flight, so on fly.io here. So what I'm gonna do is I'm gonna resolve this special address, and I'm gonna use the inet.getAddr function, and I'm gonna pass a char list, which is fly global services, as I mentioned, and then you have to pass the kind of address, which is, this is just an inet address basically, and this is gonna return okay and a fly global IP. I don't really want to care here if this can't resolve. This can't resolve. Our agent server can't start. Fine, our application will go down. Whatever. It's going to be restarted. It's going to try a few times. If it doesn't work, it doesn't work. Okay. And I return the fly global IP so that I set it to address. If this environment variable is not set, then I just return 0, 0, 0, 0. Okay, and now I'm gonna say, I'm gonna log this so that we kind of make sure that it works. So I can say starting UDP server on, and I'm gonna use a function called inet n2a. Weird name, but I don't know where it comes from, something else, but it just turns an IP into a string representation. And so I'm gonna say n2a address 5005, and it's starting UDP server here. And then I have to actually listen on this IP, and I can do that by passing the IP option to genudp.open. So here IP, and I can say address. Let's make sure that all the tests still pass. Okay, let's make sure that I can still run no halt, and this can actually log 0000. Perfect. If I try to say fly up name equals foo, so pretending to run on fly, this is going to break because fly global services is not going to resolve to anything here. We can see that we get no match, a match error here saying next domain for this fly global services. I can just play around and say, okay, what if I do google.com? It's going to work in that it's going to resolve the address, and it says starting UDP server on the address of google.com, but it says address not available, which makes sense. We can't really bind to google.com. So that's great. But it means that this is like kind of like resolving the address correctly, at least. Okay, so we also need to, yes, I terminated it. We also need to update the fly configuration. So we are going to open the 5005 port here, and we're going to open it for UDP. So by changing TCP here to UDP, okay, and we can deploy. So I'll deploy and I will see here when it's done. Okay, it's done deploying. So I'm going to grab the IP here, the public IP, and I want to try this out here as well. So I'm going to do, instead of localhost, I'm going to do this IP. Okay, so let's try to run this with the IP. It returns foo equals. Now, if I try to set it to something, foo equals 1, doesn't return anything. But if I request it again, it says foo equals 1. And we can try to request version. It says Proto-Hackers in Elixir 1.0. So it looks like it's working. Let's try it out in Proto-Hackers. Okay, so we'll go in Proto-Hackers, we'll paste our IP, and we'll go with our port number. And before checking this, I should warn you that UDP is unreliable. And I just want to throw it out there that this has been working on and off for me. So it might be a combination of Fly and Proto-Hackers being in different data centers and a lot of UDP packets being lost, or it could be like something related to Fly or something related to Proto-Hackers. I don't really know, but it's been quite flaky, so we can try this out. Usually what I see is that something passes and something doesn't. Eventually you try again, and it passes. So you can see in this case, it's not really working yet. But we saw that it was actually working when we were testing it out with just Echo. So it might be something related to UDP. I don't think I'm doing anything wrong because I've been testing this out and eventually it works. So who knows, but for now, let's just I'll check in when it's actually working. Okay, so you can see that this is starting to work. You can see that I have new logs here from my application that say that something tried to set foo equals bar, and then they tried to retrieve foo. So that's basic test and it's working. So it's actually reaching it, but then when it's trying to do other stuff, then it stops. And if I stop and go around, go back and do it again, sometimes it works again, sometimes it doesn't work, but eventually it's going to work. So you'll have to trust me on this. Try this out a few times and it's probably going to work for you as well. Okay, and before wrapping up today's video, I want to just throw out a disclaimer, which is that today we used a blocking call, genudp.receive, if you remember, in a Gen server. We used to do something like that in previous videos where we use gentcp receive, which is blocking, but we always did that inside a task, not inside the main Gen server. We still blocked the main Gen server though with our continue loop that's listening for new connections, or in this case, just receiving data. In general, that's very bad to do. You know, blocking indefinitely in a Gen server is a bad thing to do in OTP because Gen servers are constantly listening and handling special system messages that are used for debugging and for tracing and for other purposes. So for example, you can use sys.getState to get the state of a Gen server, but that's done through message passing. So if your Gen server is blocked, that's not going to work. All right. So generally, it's a bad idea to block a Gen server. So we are going to fix that by using active sockets, which are UDP and TCP sockets in active mode, where data is exchanged through Erlang messages so that everything is kind of reactive and everything ties up and works together. So we're going to do that from the next video. But for now, I just wanted to put it out there and call it out because I think it's really important that you don't go and do this in production, basically. Okay, so UDP done. As always, if you have any feedback, there's plenty of ways to reach out to me in the description below, my Twitter, my Mastodon. You can reach out or email my website, all the information, or you can just write a comment down here. Well, otherwise, thank you so much for joining, and thank you for making it through the 5th video, I believe, of this series. And I hope to see you again for the next one.